I must apologize on behalf of Risa because last minute issue has prevented him to come here. So he asked me to come and present the slides. I will try to do my best because I wasn't involved directly on the preparation of this work, but I've been contributing to the activity and I'm pretty familiar with the virtualization, infrastructure virtualization issues and so on, mainly from other projects I'm contributing. So the ones of you who know me, you already are aware of this work. Okay, so the overview for the talk is this one. I will try to concentrate on 7 points and going quickly through them. First of all, we will just explain the concept of infrastructure virtualization and the motivation for this virtualization in the scope of Jan. Also, I will talk about the activity we have in Jan so far, working with the infrastructure virtualization and the current scope we are doing on that. I will introduce you the Janus virtualization service, so the Jan virtualization service, which is called Genus, and its architecture, for those of you who are not aware about that, and how we foresee that Genus is the enabler for the virtualized operation support services, what we call the VOSS. Okay? We also have some drawback analysis and then the prototype and proof of concept of Genus. So infrastructure virtualization, many of you are most probably aware of what's that. But also, as much people as you talk about this, all of them have their own interpretation of the meaning of this. So I'll try to give you an overview of what we understand in Jan, and specifically in this task about virtualization. So two main paradigms appear in virtualization. Mainly, they are based on abstracting the physical resources on the infrastructure, not the services themselves. And if you are aware also of past projects in the community, like Federica, we can have, on one hand, the increasing the granularity of the resource, so performing some slicing or partitioning of the resource, either in network or in IT resources, or we can, the other way around, aggregate them. In networks, we are used to see that, but we didn't name it aggregation or virtualization in the past, so an ROADM ring can be treated as a single resource with a single management system, single entry point for management functions. So this is the same here. And the same is happening nowadays with the cloud management systems, okay? Because we have several resources, IT servers, which are controlled by a single entity. The same happened in the past with clustering and grid computing. So it's nothing new, but we are trying to specify what this exactly means in Jan and how the community can take profit of that. So as I said, in network virtualization, we have several topics like routing tables virtualization. We can have switch virtualization, partitioning, layered based virtualization, so decoupling the network stack into the layers we had so far and identifying services, atomic services in each of these layers, which can be used to creating more complex services and so on. And in the IT side, it's happening exactly the same. Most probably, most of us are used to see this in the IT side, but the thing here is just to take an overall view of the whole problem, joining IT on the one hand, network on the other hand, and treating the virtualization paradigms in the same way, in a normalized way. Okay, and then this leads us to the concept of the virtual infrastructure. A virtual infrastructure is nothing else than some virtual resources put together with some topology, with some common attributes, like scheduling attributes, like security attributes, whatever. And we offer this to the consumer, whoever the consumer is. It can be directly, in most science applications, the user, the end user who is running the application, but it can be in other aspects, a reseller, for example. So we can have an infrastructure provider offering a virtual infrastructure to a service provider. The service provider is not the end consumer, but is deploying some kind of control logic on top of that, and then reselling the services on top of that. So from the Genus point of view, in this context, in the context of the network and computing infrastructure, virtualization is simply the creation of a virtual version of the physical resources, as I said, based on abstract models. So for this, we need some abstraction techniques and description languages, and either achieved by partitioning or aggregating. Okay? And then we add the concept of the virtual infrastructure, which has to be worked out and specified a set of attributes, as I said before, about scheduling and security and so on. So the motivation for this is not only, as the slide says, a new era of bandwidth on demand, but also that applications nowadays are not only restricted to networks. So they require, of course, they have already required the IT infrastructure, but now we have many ways of manipulating the IT infrastructure, like cloud, like grid we had in the past, but the network has not followed the same track. So we have to make an effort to join both of them to take maximum profit of the two domains, and enabling future-proof applications, especially in research and education environment, where some users are quite demanding. Okay? And also we have quite experienced users, so those users that really want to know sometimes what they are doing or how the infrastructure is behaving, and users who don't know. So we have to be able to cope with both situations. So this information about the always, the expectation of the growth traffic and so on. But the thing is that it is not scalable at all for the operators to configure and set up infrastructures for each of the applications they are trying to support in the infrastructure. So the thing is, okay, let's introduce this concept. Let's tailor virtual infrastructure for each of the applications, or the applications which are more demanding, and then let's try to manipulate each of them independently, of course, with a set of rules and so on. So in Jan, this is being carried out in GRA1T4. It's a research activity. Currently, we are working on the infrastructure virtualization on the both sides, on network and computing resources. And also, we are trying to do the study very conscious of the multi-domain situation we have de facto in the GEAN community. Okay. So regarding this, we have a set of facts on the task, which are that many of the European research community, not only limited to GEAN, but also other FE7 projects, have done a good progress on virtualization technologies, a specification of the ways to manipulate resources, virtual resources, difference between virtual resources and virtualization based on services, which is slightly different, and the uses we can make of the infrastructure are also different. Then also we are trying to incorporate the requirements for virtualization that the different entrants along Europe may have, which are completely different depending on the kind of users and the subjects each user is doing in their universities and laboratories. And the third point is quite important. So what we are trying to do here is not to propose yet another virtualization system. What we are trying to do is just put together all the virtualization technologies which are out there, either in GEAN community or in the industrial or other FP7 community, and try to manipulate them in a normalized way so that the users can take profit of all of them, and the operators, so the service providers, can also cope with managing all the different all the different technologies. Okay. So the virtualization service that we are defining here with Genus is a group of the common virtualization technologies we have there and how to use them and specify what they can be used for. Okay? And this way we feel that we will ensure the homogeneous, or at least a basic homogeneous interoperability between all different services. Let me put an example. We can think of bandwidth on demand as a way of virtualizing resources. Why not? We can have a very low layer tunnel from one point in Europe to another site, but this service many times has to be complemented by layer 2 service provisioning, like VLAN tag and so on, in order to reach the user. So if we identify the bandwidth on demand as a virtualization technology of the JAM backbone and layer 2 or VLAN by definition, virtual local area networks, as another system for virtualization, we will register both of them in the Genus tool and allow users to coordinate these two services in order to have better support for their tests. Okay? So a number of, as I commented, a number of virtualization frameworks already exist, many of them in Europe, many other around the world, like Genie, Akari, and in Europe currently, so Novi, Geysers, Ophelia, Manticore. Many of them you can grab information from some of the stands out there in Terena. And well, this is a bit dense slide, but what we did with all these different projects is just define a set of common attributes we feel are required for defining the virtualization service, and then start studying all of them in a table or a matrix in order to have an idea on what are the common functionalities they offer and how we can represent this in the unified portal, as I will show you later. This is just a sample of the shape of the table. A complete table is in the deliverable we have produced so far, so I invite you to check it if you're interested on that. And mainly what we have learned from this initial study is three things. So current virtualization technologies are under development nowadays in different projects all along Europe and the world. Many of them have very challenging targets, but we have to see if these targets are useful or not at all for the community we have so far. Then the other thing is that we need to propose a unified way to access all these virtualization services, and finally to enable the entrants to offer these services, because some of these virtualization technologies they already have deployed on their network so far, how to offer these services in a unified way, not only to the users, but also to the different entrants and interoperating with them. So the Genus virtualization service is basically this multi-whatever virtualization stack, because, well, we have kept this multi for, of course, merchandising purposes, but if we are putting together different virtualization systems that are complementary between them, and we are defining the way they can be complemented, then we have to keep this, okay, we are able, in theory, to support any of the systems you use for virtualizing. So Genus itself is not the virtualization mechanism, as I said. We are putting together different systems and then offering the unified service. But this requires that the entrants themselves adopt this unified point of entrance to the different virtualization services in order to be able, of course, to interoperate with the others. So the approach to virtualization of Genus is mainly a bottom-up approach. So we have different resources on the infrastructure and the different management systems for them, which many times serve as an abstraction of the administrative domains. We have to be able to model the existing resources in these different resource or administrative domains, source area administrative domains, and then be able to orchestrate, because we have specified a common set of attributes, be able to orchestrate all the different services and offer them to users or other entrants. So a more specific view of this topic, as you can see on the slide now, is, okay, we may have systems which have embedded virtualization capabilities, like you can see at both ends. So these entrants have already systems for partitioning their resources and creating these slices, like we have in Federica, for example. But if we want to communicate these services, we have to orchestrate this with a bandwidth on demand system, for example, in the Jan backbone. So the idea is that for allowing these two separate experimentation virtual infrastructures to work together, we have to orchestrate the service with Autobahn in this case, or the VOD service. Oops, oh, sorry about that, because this is an old version of the slide set. Okay, so the genus architecture as defined currently has been defined to be working both hierarchically and distributedly. This is the hierarchical way it works. So we rely on an enterprise service bus as other activities inside the GM projects, because one of the main things we want to have there is interoperability, as I said at the beginning. So we specify adapters for the different systems of the different entrants and the different administrative domains, and we provide the very lightweight intelligence for orchestrating these different services. Also, we need a registry and a user interface, and what is more important is that we have to be able to talk, for example, like you see in this slide, with the Jan multi-domain bus, which is a meta bus for orchestrating service in Jan, not only network and infrastructure virtualization services, but, for example, video conferencing, security, and so on. So the way distributed it should work is mainly using the capabilities of the enterprise service bus. So we may use the message broker at each of the ESBs to share signaling between the different genus services, the different genus deployments. And of course, we included in the deliverable a drawback analysis on the adoption of the genus system, okay? Mainly based on three areas: technically, in terms of service, and in terms of business. Okay? Of course, you can find more details on that on the deliverable. So the basic services we want to offer in the early prototypes of genus are basically the registration of facilities, of course, the registration of these different administrative systems, administrative domains in the entrance. Also resource discovery to have the two ways registration of resources, and the basic functionalities for requesting virtual infrastructure and decommissioning the virtual infrastructure. Coming a bit back on the presentation, I told you that for doing the virtualization, we need to abstract the network resources or the administrative systems, the NMS, whatever. So for this, we have gone for a solution which is currently developed in different European projects like Novi and Geysers, which is using an information modeling framework based on RDF. So we create a full-fledged ontology of the infrastructure, and we add as much details and as much specific resource characterization as needed for each of the systems. Okay. Well, the current Genus prototype, apart from the functions I commented to you before about registering facilities, decommissioning facilities, and so on, it's planned to work with 3 adapters, one for the services in the Manticore project and the Open NAS system, another one for Ophelia. So this means we are introducing also OpenFlow technologies in the bus, and another one for Autobahn, which is already in place. Okay. This is the main view of the portal as it is now, just the welcome screen. And in the different snapshots of the different screens you may find. Okay. So you can see on the upper part we have the different sites, different facilities like Autobahn, Manticore, and Ophelia, the information which is needed for that. And I'm afraid you cannot see that on the lower part. You have also the characteristics of the different resources you can find on these facilities. This is an extended description of the facility, which has specifically the management, location, and general contact information for that. And this is a very light depiction of the current testbed. All what we are doing now, as I said, is relies on existing projects. So as you can see, many of the blue bubbles here are project deployments which are maybe in or out of the GEAN, but GEAN infrastructure is vertebrating the whole testbed right now. Okay. I will go quickly through the use cases that we have so far. So first of all, the video on demand streaming, the ultra high definition video on demand streaming, which is a well-known use case. In this case, what we put together is the video facilities on the one side, the computing facilities on the other side, and the network provisioning. And we offer these 3 different shape of resources as a single virtual infrastructure for the user to play the experiments. The same way, on a more detailed vision, is what you have on the screen now. So let's use the Ophelia, Autobahn, and Manticore testbeds to produce these abstracted views of the scenario and remove all the complexity of dealing with the different systems and different resources in the physical infrastructure. And Genus prototype, the first release is foreseen for July this year, and the final release will be for almost for the end of the project in 2013, April 2013. And that's pretty much all. And again, I apologize for my quick explanation on behalf of Risa because he didn't manage to come.
Okay, thank you very much. Some questions?
Hi. So you mentioned about the other initiatives, like, for example, Genie or Planet Lab. Some of them, the most known ones out of this group, have turned into the Slice Federation architecture, RSpec specifications, and so on, to do, let's say, announcement and brokering of the resources in the multi-domain environment. Mm-hmm. So what's Genus adding to that? What's the difference? What's the added value? How do you stand against it?
The thing is that Genus is not doing, again, what these other projects are doing. What Genus may do is help registering all these facilities in a unique GEAN portal for letting the users know that they can reach these different experimentation facilities using the GEAN services. So the thing is that they will get these facilities registered in the portal. This means that they can access them through the GEAN backbone and the current services, or that they can grab different services from the portal to reach all these facilities. And then the experiments go on a different way. So this is signaling and so on. Trying to summarize. So currently, you may have all these facilities which are not connected to the Jan network, so you have to do a lot of work in order to reach them or reach them through the internet, which may not assure you the quality you expect for your infrastructure, for your experiment. So the thing is that if these facilities are connected somehow to Jan, they will be registered in the portal, and you will have access to the information about these facilities and how to use them. So you can take the decision to combine different services on the virtualization portal to reach them and interact with them in a more seamless way. And then avoiding one typical problem, which is, okay, the user doesn't know how to get there, and the most easy thing to do is do everything over the internet. So this is a failure. For Jan itself, because we have the infrastructure connected to them, we have different technology which allow us to reach them. So let's put this into the knowledge and allow them to use, in a unified way, these resources. Yeah. So it's making the bridge to there. It's not doing what they do, it's creating the bridge to them in a unified way.
Some more questions? Nobody? I have one. So what is the probability you will find the real users, and who would be the real users of this system? I know that you have some examples, but what type of users do you expect from the entrance or from where?
The users can be all the users of the different systems we have shown so far, and also, why not, the different experimenters connected to Jan Bankbund that need to use the resources. Okay, so for example, we can have even the entrants being users of their own system. Let's say, currently we have different mechanisms for provisioning different technologies all along the Jan backbone, but some of them are not yet in production. For example, let's say OpenFlow, because there's a lot of work being done in OpenFlow right now. So since this is not a production service of Jan, it is difficult to do some testing with that. If we register this experimental service in the portal, we may have the information on how to use that on beforehand, and then have more experience on that for doing future works with that, or offering experimental services to the users before production.
Okay, thank you very much again. I would like to invite our second speaker, the Aphrodite Sevastri. From GRNet. He's the head of the commercial part of the Chief Business of Development Office, GRNet. And he's also the GN3 project member of project GN3 manager team, and she will have a talk on the internet testbed.
So good morning, everyone. Thank you. It's still morning, I believe. Is it on? Okay. So it's still morning, I believe, for everyone here. Thank you for joining this session. This talk is about some high-level aspects and prospects for Giant, offering testbed facility and services to its user community. This work is still in progress. It is following some very recent tender concluding on the upgrade of Giant, the upgrade of equipment and the upgrade of capacity of Giant, and obviously enabling testbed facility offerings in this new infrastructure will follow the deployment and implementation of the new backbone. Actually, I think there is a press release about this to be released tomorrow. So I think most of the people in the room know about Giant. It's the Pan-European Research and Education Network. It's a multi-domain environment because we have the national networks attached to it. It is serving 37 or more NRENs, thousands of campuses and millions of users. It is serving the community with a number of advanced services and unique offerings. However, it has
still a lot of potential. It has some capacity which is still unused. The new generation Giant will have a lot of technical capabilities for even more advanced service offerings. And as such, it would be an ideal environment for delivering testbed, testing and testbed capabilities to the user community as a service, especially since this is a wide area infrastructure and user communities with research requirements on wide area infrastructures would greatly benefit from that. So looking into the evolution of testbeds or internet testbeds, we have seen them traditionally being platforms and infrastructures available for experimentation, usually physically separated, isolated, detached from the production environment. So you were given an infrastructure to play with. It was not in any way related to a production environment in a way that your experiment or your disruptive work could harm production traffic. And as an example, you can see a testbed that was set up in Giant until some time ago, which was a small replica of the production network. It was utilizing SDH switches, interconnected with dedicated STM64 lines, and it was given to mostly to the project participants for testing. The operations teams of Giant were testing GMPLS and new features of the equipment, and some teams working within the community on dynamic bandwidth on demand provisioning were testing their software there on that testbed and so on and so forth. All this was detached from the production environment, and all this was time shared, so no two user experiments were able to be run on this infrastructure at the same time. However, recently, virtualization, slicing, like John spoke about previously, have changed the landscape. The technologies are giving us more capabilities to do testbeds. We can do test facilities that coexist with production environments. And more interestingly, the community is very active in the last years in developing solutions to federate and broker testbed facilities in the multi-domain environment. So there is a lot of evolution happening, and the idea here is to see how can Giant follow that. So here's a nice figure I have borrowed from a very known paper on OpenFlow. This is showing in graphics the trend that I was speaking about just earlier. You can see in the bottom, in the top middle picture, a physical network, switches, links, the physical infrastructure. You can see in the figures on the left and the right-hand side, topologies configured on this physical network and delivered, given to specific experiments. And on the bottom middle picture, you can see how these topologies lie on the physical network and coexist with production traffic. So it's a very good visual of how testbed facilities are delivered today. So before going any further, some terminology. What can Giant be? What can Giant become in such an environment? This terminology is more or less common in similar initiatives globally. So I hope I'm not, let's say, conflicting with Jean's presentation and any other presentation in this conference this year, which is using these terms more or less. So Giant can be a substrate, can be the set of physical resources upon which testbed topologies can be provisioned and delivered, including links, network, and computation elements. Out of these resources, the virtualization technologies or other technologies can give us the capability to partition them and give away these resources to users. There is here two different ways to do it. The differences are small, but they exist. We can either slice a resource by compiling a dedicated partition of it, an exclusively used section of that resource, and we can virtualize a resource using some abstract model, making sure that the virtual partition of that resource is imitating or is having most of the properties of the resource that we had in the physical space. So either with slicing or with virtualization, we end up with functional partitions of resources which are then able to be combined in what we call a slice, a testbed facility composed of network and computing slivers dedicated over a substrate to a specific user or user group for experimentation. So this is more or less a high-level taxonomy of how can we organize things. And knowing that Giant can be a substrate, here is a quick view of how can we slice Giant resources as they are today, as they stand today, with a number of different technologies, and use these resource slivers to compose testbed facilities and deliver testbed functionality to users. So at layer 1, we can have all-optical lambdas, we can have static all-optical lambdas or dynamic ones. We can have dynamic regenerated lambdas based on Giant equipment. At layer 2, we can slice the capacity and the links by carrying client signals over OTN, or using VLANs or Q&Q technologies. We can even use Ethernet over MPLS to link the slices. At the layer 2, we can also use OpenFlow or software-defined networking, more general technologies, to even slice network elements in their control plane. At layer 3, we have been traditionally using IP and GRE channels and differentiated IP services to partition links and segregate different streams of traffic. But more recently, we can even do that on the hardware. We can do hardware-based logical routers, and we can also have software-based routers hosted in servers. So all in all, we have a tool set we can use, and with the new Giant, the next generation backbone of Giant emerging, as it will be announced tomorrow, these capabilities are there, and they will continue to be there and enriched. So we are able now to slice the resources and deliver slivers of network resources to compose a network slice over Giant. This can be done simultaneously on a multi-layer facility, or it can be done in different combinations. Here I'm putting down a list of all the different options we have. We can deliver photonic point-to-point links in all optical add-drop multiplexing facilities, which are attached to the Giant fibers, because Giant is a fiber-enabled network. We can have native or emulated point-to-point layer 2 links using OTN or Ethernet over MPLS. Both of these will be possible in the new Giant. We can deploy SDN OpenFlow to deliver a shared and forwarding data plane and a sliced user-managed control plane at layer 2 over Giant. And of course, we can try to deploy interconnected logical routers, which will deliver a layer 3 sliced control and management plane, while the data plane is still shared among the users. So a lot of options, a lot of possibilities, and at the edges of this network slicing options, we can always attach computation slivers in the form of user-allocated hosts utilizing server virtualization. So this is an overview of what can be done. Now, in order to decide how should we go further with this, we have taken a look at the use cases which are out there and which could benefit from Giant offering of testbed and testing facilities. The asterisk over there demonstrates this is not an exclusive list, okay? This is just an indicative list. We're open, we're here to get more ideas and more use cases for this work. So first of all, there is interdisciplinary research with network facility requirements, any kind of research which is using the network as such, any kind of experimentation which is using a layer 2 or layer 3 network as such, peer-to-peer networking, client applications, streaming applications, any kind of application at layer 3 and testing at layer 3 and above, which can benefit from a layer 2 or layer 3 infrastructure, or more generally, research on protocols and services running on the internet is a category by itself. Then we have a lot of upcoming and emerging research on software-defined networking, so researching on the concept of software-defined networking itself, flow control, segregation of forwarding a control plane, research on OpenFlow itself, its performance, its capabilities, and so on and so forth. This specific type of research needs a testbed facility and testbed properties, which will segregate the substrate layer 2 or substrate carrying technology from the slice technology. So just to give an example, we cannot afford to run such experiments on a substrate which is switched on VLANs, which is functioning based on STP and so on and so forth. So the slices we need to give out to researchers working on SDN have to be entirely clean and agnostic in terms of layer 2 functionality, Ethernet layer 2 functionality. Otherwise, they will have limitations on their experiments. Then moving further, there is a group of use cases on data center interconnection. There's research currently happening in load balancing between data centers or live migration of virtual machines among data centers. Again, this is a very good group, candidate group for experimentation over testbed facilities and beyond, because in most of these cases, these data centers are distributed and they're expanding in a wide area. So what would be more suitable than an environment, network testing environment in a wide area to test the protocols and the research done in this field? Then moving further, we have a big group of use cases with research on layer 2 and layer 3 networking. Again, here there are some examples which are indicative and not all-inclusive. So we have, for example, I have a group right now in my team in Giant who is working on multi-domain Ethernet OEM, and they needed a testbed facility to do their work. Policy-based management in multi-domain environments, control plane tools, inter-domain control plane tools and protocols, they all need testing facilities to be developed. For example, research on energy efficiency of network footprint. So there are people working right now on controlling the management plane to switch on and off traffic and equipment to achieve the minimum energy footprint at short time intervals at some points. In all these cases, each family or smaller group of use cases has some very specific requirements from the underlying substrate. So not every substrate, not every setup would serve their needs. So we're trying now to see, for example, if you want to run a control plane tool test on top of a testbed facility, you must not have any other kind of control plane functionality mingling with your work from the substrate. So the segregation of substrate functionality and capabilities and the equipment, the experiment, functionalities has to be very clear. And we're trying to use this taxonomy of use cases to drive us into selecting those combinations of slivers and those combinations of slices which would be most suitable to support in Giant. And last but not least, there is some very special cases that we have in our community, special, for example, metrology research from the Euromet Association, which needs high accurate time and frequency transfer of data, and for which slices at layer 2, layer 3, and above are useless. They need an all-optical layer 0 slice from Giant, because they're usually, again, doing it in the wide area environment. And then now we're in a process where we need to match use cases with substrate facilities. So for example, research on data center interconnection can be done both in a layer 2 substrate, which is delivered with native or emulated Ethernet circuits, but could easily also be done using OpenFlow in many cases. As already said, some special purpose scientific research needs all opticals slices and all optical substrates, and so on and so forth. The figure is here to show that there are many combinations and there are no, let's say, easy answers. But we believe that by systematizing and creating this taxonomy of use cases, we can come up with the most needed and the most appropriate substrate configurations among the many options we have for Giant to serve the user community. And here I have two scenarios that we have worked on. They're very conservative because we are just now starting. Although I promised in the beginning that we will eventually be working and delivering the services on the production environment, we cannot do that yet. So what we are trying to do now is design some testing facilities that will reside outside of the production network, but integrated with the production network. So here we have an indicative setup for introducing OpenFlow into Géant. So we're deploying OpenFlow switches next to Géant POPs. We're having servers which are virtualized to deliver user hosts, OpenFlow controllers, OpenFlow proxy controllers. We are providing in-band and out-of-band capabilities for control traffic for each of the slices in this infrastructure. And we're designing this in a way that later on, when we feel confident about it, we can migrate the functionality of slicing within this facility from a standalone OpenFlow switch next to a Géant POP into the POP equipment itself. For example, utilizing vendor capabilities to support OpenFlow, which are being announced more and more often these days. And then here is another very high-level and conservative scenario where, again, we have designed the deployment of vendor gear, which is supporting logical router functionality, and we will be slicing this equipment into multiple user-managed logical routers, delivering layer 3 slices over Géant. Again, there are many ways to do this, but these are just some of the ideas we have started working on. And again, this can be then instrumented in such a way that later on this functionality can be moved onto the production network so that slices and production traffic can coexist on the same hardware. So if we want to look a bit higher than the data plane, into the features that such a service and infrastructure and facility should support, starting from the provider point of view and going all the way to the user point of view. First of all, a provider who wants, like Géant, who wants to have testbed facility offerings on their production environment have to orchestrate the operations of the substrate on top of the physical infrastructure operations. And this is not a straightforward thing to do. It's a challenge. Then the provider has to have management and provisioning tools for the substrate. He should be able to announce the available infrastructure, substrate infrastructure, and service access points to potential users. He must have a cost model to compensate for the physical resources, accounting for each of the slices. And turning more to the side of the user should be able to model and submit their requirements in terms of not only capacity, but also functionality needed and functionality which must be avoided from the slices offered to him. For example, if somebody is doing, as we said earlier, a layer 2 research, they cannot afford to have a slice which is putting limitations on any kind of layer 2 functionality that they want to test. Then usually users require APIs for basic network and host provisioning management within their slices so that the service is provisioned, the testbed is provisioned to them as a service. They have full control of their slice. And last but not least, the user want to have tools behind the API, management tools to control and monitor the behavior and the characteristics of their allocated slice. So this is, again, a quite high-level view, but this is, let's say, a variety of features that need to be supported by such a service offering to make it viable. And some business aspects, some success factors for such a deployment. The installed infrastructure has to be compatible with operations and services of the existing network. In most cases, when you have a test facility, because it's an experimental environment meant to be disrupted, SLAs are suddenly less important, but we think that these are equally important Reproducibility is also very important in these cases. We need to be effective in making this match of offerings that will maximize the number of research experimentation initiatives that will be supported when this will be in production. We also depend a lot on the maturity of the supporting technologies like SDN. And of course, in all such cases, because GEANT and the attached NRNs is a multi-domain environment, but still their reach is not within the campus, the reach is not within the lab that wants to use this infrastructure to do experimentation. User access and last mile are always very important. So we're looking into these aspects right now. We're expecting the next generation GEANT to be announced and implemented in the coming months, and we will be working on these aspects shortly. So I appreciate your attention, and I would like to stop here.
Okay, thank you very much. So you have a chance to hear the nice perspective of the next GEANT playground, as I understood. So we have also heard about some tools which we are or they are planning to use. Okay, so more question, please. Okay. So
you're returning the favor. Eh?
It's just a quick question, because you said that for this new environment, we have to make coexist this experimentation, not so stable services with the stable backbone. So what is the initial approach you are taking for that? Are you forcing, for example, technology islands attached to the backbone to start playing there and then progressively interconnecting them, or do you have any other idea?
Okay, I think the idea was more or less what I was trying to show with the two scenarios that I showed. So we don't want necessarily to see GEANT as simply interconnecting islands, testbed islands, which exist in Europe. We know they exist, and we are already interconnecting them, and we will continue to do so. But we also want to enable the GEANT backbone itself in supporting some of that functionality. Because, as mentioned earlier, the capacity is there, some of the functionality is or will be there shortly. So going one step further than just treating GEANT as a network which can provide point-to-point links, okay, we think that there's more we can do there. And of course, once this is enabled in the backbone, this can again peer or exchange testbed resources with other testbed facilities, as GEANT is already doing. So it's an additional piece of work. It is not by any means neglecting what is around GEANT and interconnecting the testbeds and interworking with them and so on and so forth.
Okay. More question? Yes, okay. Go ahead.
And following up this first question and answer, I would like to know how many resources or an order of magnitude of resources which are not network that you plan to include and integrate in GEANT for this.
Mm-hmm. Okay. I would not be able to give an absolute number. What we're doing right now is we're deploying some computation facilities in some of the POPs. This is will follow an incremental process. I mean, currently we have specific needs and requirements which are mostly project internal, and we're trying to cover these. We're deploying some OpenFlow capabilities in the POP, so we have dimensioned a little bit some server hosting space for user equipment to reside in the POPs and interplay with the OpenFlow. This is constantly, let's say, increasing. We have some currently with the current, for example, support for the OpenFlow part of what we are doing. We're aiming at something like between 5 and 10 concurrent slices. So you can think of about 5 or 10 hosts at its POP, virtual hosts, which can be participating to the different slices.
I have one question.
So are the user cases that you presented based on some real user requirements? Have you surveyed users, and in general, what is the adoption of such services in the last years?
Okay, most of these use cases, there has been no wide and systematic market survey. Most of the use cases presented here, all of the use cases presented here are real. They come from either partners of the GEAN consortium or affiliated members, institutes around Europe which are already working in these areas. We aim to do a more systematic survey. We have specific cases among those on the list where the groups have gone away and set their own testbeds to do their work, even within GEAN. So there is a business opportunity there. We have not fully systematically addressed that yet, but we're starting to.
What are your milestones, or when we can play on this?
Okay, I won't be able to answer that, mainly because, as I said in the beginning, we're now, the most urgent thing in GEAN right now is the deployment of the new backbone. As I said, there will be a press release tomorrow, and those who will take a look at it will understand that it's a very massive thing. So this will be #1 priority for quite some time. In parallel, we are doing this background work. I don't see that happening before a year's time scale, because as I said, this depends on the new backbone, and we have to wait for it to be up and running first. Maybe a little bit more even.
Okay, thank you. So, more questions? No? So, thank you very much.
Thank you.
Okay. Our third talk would be from Miloš Přivěcký from PSNC, or the Polish Supercomputing Center from Poznań. And the title is Federated POPs as a Successful Real-World Collaboration. So there are many co-authors of this, so please, floor is yours.
Thank you very much for your introduction. My talk will be a little bit different than the previous two. The previous two were more like on the architecture and general view on the issues. My talk will be based on some experiences that arise from the establishment of federated POP. So the brief outline is, first I would like to say a few words what it is and why we made it. Then I will talk a little bit about the features of this federated POP. Then I will share some experience from the establishment. And finally, I will say a few words what are our future plans and what can be expected in future from this. So first, maybe some background, how the federated POP was born. It was born from the work of the JA1 Task 3 Federated Network Architecture Group in GEAN. It was alive during first 3 years of the project. The task is already finished, so the federated POP is an effect that's still living, but the work has stopped in the GEAN. The team consisted of CARNet, DFN, NorduNet, PSNC, RedIris, and SurfNet. And the main objectives were divided into 2 parts. During the first 2 years, we did a paper, state-of-the-art study on the network architectures. We are investigating different options and trying to find some common denominators in order to think how to federate the networks. And in the last year, we tried to establish a real-life example of such federated network architecture. So definition of the test case and testing was started last year, and it's still we are still doing it. So, what is federated POP? In our opinion, in our, let's say, definition, we define a federated POP as a physical site where several networks like NRENs or JANT are collocated to offer service in a joint manner. So we are bringing several networks together in order to make them, to enable provisioning of common services. What is more important is in the second sentence. Inside the federated POP, network operations are carried out in accordance with collaborative agreements, and equipment is shared where possible. So our aim was to share the cost, share the equipment between the networks. You might ask why. Of course, I said it's possible to share the cost. If you are sharing the equipment, then probably you are able to save some money. The same goes for the operation. Common operation of the equipment can bring some savings. The second reason, it allows to optimize somehow the networks and the CBFs that NRENs are using. Next, that's what I said previously, it's possible to provision common services. The fourth advantage brings it allows to increase the resiliency of the overall network. And of course, it opens opportunities for collaboration. The NRENs are working together, so there are another reasons to collaborate. Okay, during this research phase, it's quite simple. We identified 4 main types of federated POP. It could be a very simple, lightweight, optical-only federated POP. It can be switching when the optical stuff is enriched with switching, routing when we have optical and routing, and full service that includes all of this, so optical switching and routing. Due to, let's say, due to features which are supported by the equipment, the number of services that could be provisioned through this federated POP can vary, of course. So what is the genesis? After the research phase, we are thinking about the test case that could verify our concepts regarding the federated networks. So we distinguished 4 main test cases that could be used for validation of this research work. It was using CBFs for JANT POP-to-POP connection. It was the idea to replace dedicated JANT capacity by CBFs. The second idea was to use CBF as an element in regional links to reduce the cost of connecting to the JANT POP. The third one, it was idea to increase resiliency by providing the remote IP backup with the CBF. And the fourth that we selected was the federated POP. So the one place, one POP where we are sharing the equipment, where several NRENs are meeting together. And I will say why on discussing the next slides. So why we have chosen this one? We had a situation in Hamburg where we have 4 NRENs already in the city. So we have, of course, DFN, because it's in Germany. We had Nordnet, Pioneer, and SurfNet. And the lucky situation was that the Nordnet, Pioneer, and SurfNet are located in the 2 nearby collocation centers. In fact, it's in one building, and these are 2 rooms. Nordnet and SurfNet are located in one collocation in one room, and Pioneer is in the second one. The second reason was that the NRENs who are present in Hamburg had their representatives in our group. And the next very important reason, that's the collaboration between NRENs was already established. Here we can see the situation before the establishment of the federated POP. As I said, the collaboration was already started. So this is the picture of the interconnections before the federated POP was established. In the top part of the picture, we can see Nordnet and SurfNet located in the first collocation center. In fact, these are just two cabinets standing side by side. And on the lower part, we have a PSNC Pioneer. So the Nordnet and SurfNet was connected with one 10G lambda and with Alienwave. The connection between PSNC and SurfNet was by two 10G lambdas. And there was also one 10G lambda between Nordnet and PSNC. After the introduction of the federated POP, this is the general picture how it looks like. So in the center of the figure, we have the Ethernet switch, which refers to this switching type, the second one. It was driven mostly by available hardware. And the switch is located in the SurfNet's cabinet. It was provided by PSNC, and we placed it in the second collocation center. It's in the SurfNet's cabinet. So we are somehow sharing the cost. SurfNet maintaining the switch in the cabinet. We are providing the equipment. And currently, we have SurfNet at PSNC and Pioneer connected to this switch. Connection to Nordnet is already done, but we need to do some troubleshooting, do some wrong patching on the site. So I think soon it will be also ready. Currently, we have Autobahn controller on top of this Ethernet switch, and this is I must admit this is still changing because it's living. And probably it will be a separate domain just for this federated POP. Okay, that's for the overall picture. Okay, during the research work, I will show you how we divided the federated POP into 3 layers. This is, I think, a little bit obvious. We have infrastructure layer at the bottom, so we have all the equipment in the infrastructure layer that is shared or owned by the NREN. Then we have operation layer where we have NOCs and all stuff like that. And on the top we have services which are provisioned through this architecture. Having this picture mapped on the Hamburg case, we have 3 NRENs with this switch located in the SurfNet's cabinet. So that's the infrastructure layer. Also, of course, the patching and the connections to Hamburg, because comparing to the first picture, all NRENs had to provision additional 110G lambda to Hamburg just for the case of the POP. Then we have operation layer, where we have network monitoring systems in the NRENs. Switch is monitored by PSNC. Of course, NOCs are cooperating with each other to make it working. And right now in the service layer, as I said, we have let's say, initial bandwidth on demand service, because it's right now only Autobahn, but the service needs to be tuned, of course. And we are thinking about different services. Any proposal is welcomed, because it's kind of test bed. We are looking for some ideas just to test, just to validate the idea. here we have a picture showing how it's organized. So we can distinguish three main roles, three entities which are involved in the Hamburg POP. So this is general example that I mapped into the Hamburg case, because in our research work we distinguish the FPOP owner, who is providing the space and all the resources needed to run the equipment. In our case, it's an external entity, the owner of the collocation center. In general example, if it will be, I don't know, located in the NREN's premises, it can be NREN, of course. But in our case, it's an external entity which is completely independent from the NREN's. Then we have FPOP host, which is SurfNet, that is providing communication between NREN's and the FPOP owner. So in case PSNC would like to do some physical work with the switch, we need to go through SurfNet, because SurfNet has a contract with the collocation center, and it works in the past, so it works quite well. And then we have FPOP members who are using the POP, so we have these three networks. And then in the middle we have a Hamburg FPOP pilot team. These are people who are involved in the JR1 task 3 activity. In fact, most of the initial work was made by this team. And now the part of the responsibilities are moving to the regular teams of our NRENs, so the role of pilot team will be lower. So sharing some experiences, how we did it. In fact, we can distinguish two kind of steps needed to establish such POP. Technical and non-technical. This is also quite obvious, but I think it's quite important to enumerate this. So in order to set up such place, of course, we need to have a connectivity. In our case, we had this CBFs, so it was quite easy. We added just another lambda in the system. Taking into account that we are located in the two collocation centers, we also had to provide the connectivity between them. PSNC had to go through the special patching to reach the switch. The third bullet point is also quite obvious, but it's very time consuming, because tuning and agreeing on all issues that are related to the establishment and placing the equipment can be quite lengthy and sometimes surprising. And of course, then we are making the installation, and the selection of services, in fact, is happening continuously, because before you are establishing the federated POP, we are of course thinking about what we could do on top of the architecture, because for making just the federated POP, it didn't make sense. So of course we thought about it before we did it, but we are still thinking about it, because now it's living and there are some opportunities to set up some services. And there are of course non-technical steps. So we need to be let's say sure that we would like to do this. We need to allocate resources for that, because we need to maintain the connection. We need to make some new procedures between groups of people who are dealing with the operation of the POP, because the switch is, for example, PSN switch is in the cabinet of SurfNet, so it's we need to contact them in case something is happening. Of course, then we have also allocate some necessary manpower to do the day-by-day operation. This is not a very difficult thing, as this can be added to people who are normally working with the operation of the infrastructure of the NREN. And of course, we need an agreement on operation between the parties. In our case, these are more like agreement that we are doing this. There is no formal agreement yet, so that's we are basing on our, let's say, common aim. So for the future of the federated POP, we are thinking about new services if needed. Of course, we can test them as a separate domain. The operation of bandwidth on demand-based service using this Autobahn instance that is running on top of the infrastructure will be further investigated. And of course, we need to tune our procedures, our initial procedures that we set up between the NRENs. I'm sure that during the using of this infrastructure, some problems will arise. So I guess some tuning of the operation maintenance will be needed. Before I say thank you, I would like to also mention that we have also a poster, and so we can also make a short discussion during the poster session. Will be available nearby the poster. So thank you very much, and if there are any questions.
Shall I start? Yeah, so I'm Guy Roberts from Dante. Very interested in your presentation. Thank you for that. In JMAT, we currently have a POP in Frankfurt, which gives a primary access point into for DFN, and we obviously we've been talking to DFN about the possibility of an alternative access point for them, and we actually have fiber that runs through Hamburg. We actually have two fibers that run through Hamburg, Copenhagen to Amsterdam and Copenhagen through Hamburg to Frankfurt. And we're interested in also having a potential second point of presence for Germany. How do you see that fitting in with this? With your proposal?
Well, I must say that we are very open. Of course, from the beginning, in fact, we are always saying that we are open, and if there is a possibility to include any additional network and do some more cooperation, it would be great.
Stephen Wolf from Internet 2. The NRENs in question at the FPOP are also interconnected through the GÉANT network. So at layer 3, how did you arrange the routing, and can you comment on the division of traffic between the multiple interconnects?
Right now, we are not. We don't have a layer 3 traffic going to. We have an Autobahn on top of that, so this is provisioning of the layer 2 circuits right now.
I have one.
Okay.
The fundamental question is why the other NRENs operate on the territory of other NRENs is the first question. So in the Hamburg was probably the HERA facility was there, and that was the reason why the SARA or other physicists are trying to get the data from that. And okay, and after that I would like to know more about the practical operation. So how you work on the federalization. So the one thing is that there are 3 or 4 type of the NRENs participating, but what you said, the agreement, you have to have an agreement. If this agreement is somehow formalized. Okay.
Okay, so answering your first question. We thought about the federated POP because the fibers were already there. We had the cooperation already there. So why not? Okay, that's the, let's say, simple answer. But of course, you may think why. But we are already cooperating there. We can optimize the connection that we already have, thanks to this equipment that we placed there. And answering your second question, as I mentioned, the agreement is more like not formal. So we are making some experiments right now, and as soon as we put more services, of course, agreement will be needed. We are trying to find some rules how to cooperate on operation of such POP. It's not usual. So based on also we have some let's say hints in our deliverables that we did in the first 2 years, because we tried to define some framework for that. I think as soon as it will be necessary, as soon as we go into, let's say, stable production phase, the agreement will be in place.
Okay, thank you. So Peter had another question.
Yeah, Peter Kaufmann from DFN. I might make a small comment for that POP. I'm also part of that group, and DFN was eager to participate also with the 3 other NRENs to operate that experimental POP. But as we are currently in a change to a new generation of the Wissenschaftsnetz, so we have ordered new equipment, and so we have not been ready at that time to draw a line, to put equipment on the line. So we hope, let's say, that next year, when we have established our network, that might be changed. And we had assumed in our group that also when Xi'an is ready with its new implementation of the new equipment, its new network, as mentioned already, it would be the time to think about a new federated POP, not only for the currently experimental participants, but to go on and to open that experimental POP to a wider, even maybe production environment.
Okay, thank you. There's another more. Can we expect the more federated POPs in Geneva or somewhere also?
Yanis Mitsos from GRNet. One question. You mentioned that this work has been carried out in the context of a joint research activity, even though to my eyes it's more than a service activity. It doesn't have much research, let's say, focus. I would like to ask you, what were the outcomes that were delivered as a product of this work? I mean, you have done your experiment. Was something concrete, recommendations towards the giant community, Dante, on how to expand further, or how this should be further, let's say, used in other communities?
Yes, the answer to your question can be found in our deliverables that were in the first part of our work. I mean, the first 2 years. We had 2 deliverables. In fact, the second one will be contains more information about that. We tried to find outlines, some information, some guidelines on establishing similar federated architectures. The year in the third year was most focused on the test case, trying how to build and how to verify it in the real life. So if you are looking for some information, I would try to look for it in our deliverables, especially from the second year.
Okay. More questions? No? Okay, thank you very much.
Okay, thank you very much.